The convolution integral is one of the beautiful concepts in signals and system, and it has some properties. Knowing the properties of convolution integral will help us to solve the problems in a quick manner, or we will get deep insights about the convolution integral itself. So what are the properties? The properties are commutative property, distributive property, associative property, shifting property, integral property, width property, convolution with impulse property. So now let us go into the video and try to understand and what are the implications of these properties.
Now let us see some important properties of convolution integral. The convolution integral have so many wonderful and interesting properties. So this will make our life much more easier while we solve the problems, right? So the first property is known as the commutative property, right? So what the commutative property says, if you convolve a signal x1 of t with x2 of t, which is equal to convolving the signal x2 of t with x1 of t. So that means changing the position of the signal in the convolution does not change the result. In both the cases you will get the same result, that is x1 of t convolution x2 of t is equal to x2 of t convolution x1 of t, right? The proof for this I am not covering in this video, which is available in the material shared with this video. Please download and see the proof. It is very easier. We can easily understand it using a graphical way. Assume that we have a system with response x2 of t. Here please note that x2 of t is the response of the system. And if I am convolving the signal x1 of t to that system, so here the convolution operation is performed inside the system, then you will get c of t. On the other hand, if you have a system with the response x1 of t, and if you convolve the signal x2 of t with that system, here also the convolution operation is happening. If you convolve x2 of t with that system, then also you will get the same result, that is c of t. So changing the position of the signal or changing the system response and the signal between each other does not change the result, that will be same. That is what the commutative property says. The distributive property says that convolving a signal x1 of t with the sum of two signals. What are the sum of these two signals? x1 of t plus x3 of t is equal to adding the convolution of x1 of t and x2 of t with the convolution of x1 of t and x3 of t. Graphically it can be explained like this. Assume that we have a system with system response x2 of t plus x3 of t, and we are going to perform the convolution operation inside this system. If you give the signal x1 of t inside this system, it will perform the convolution operation and it will produce c of t. Now the same c of t can be obtained in a different way. What is that way? You give x1 of t to the systems parallelly like this, right? The system response of this upper system is x2 of t and the system response of the lower system is x3 of t. Now if you give the input signal to these systems, it will convolve and you will get x1 of t convolution x2 of t, and here you will get x1 of t convolution x3 of t. If you add both of them, you will get the same c of t which you have obtained here, right? So this is what the distributive property says. The associative property can be explained like this. Convolving the signal x3 of t with an already convolved signal. What is that already convolved signal? x1 of t convolution x2 of t is equal to convolving our signal x1 of t with an already convolved signal. What is that already convolved signal? x2 of t convolution x3 of t are equal. So these results are equal. That is what the associative property says. So it can be graphically understood in this way. Assume that we have a system with response x3 of t and the operation performed inside the system is convolution. you are providing an already convolved signal x1 of t convolution x2 of t to the system, you will get C of t, right? The same C of t can be obtained in two other ways. What are they? First, you give x1 of t to a system with response x2 of t, and you perform the convolution of these two, and you take the output. So what you will get output? You will get x1 of t convolution x2 of t here, right? And you give to the next system whose system response is x3 of t. That will be equal to C of t. That will be equal to C of t. That is what this associative property says. Also, this can be obtained in another way. You give x1 of t as the input signal to a system whose system response is x2 of t convolution x3 of t, and you perform the convolution. Then you will obtain C of t, that is x1 of t convolution x2 of t convolution x3 of, right? So you will get the same C of t in three different ways. This is what the associative property says. Now, next, coming to the shift property. The shift property says that if you shift any one of the convolution signal, any one of the signal which is convolving each other, that shift will be reflected in the output also. If you shift x2 of t or x1 of t by a time t, capital T, the shift will reflect in the output also. The output will be shifted by t units. This is what the shift property says. If you shift both x1 of t and x2 of t, then the total shift in the output will be equal to C into t minus t1 plus t2. Otherwise, we can say that the sum of the shifts will be equal to the shift of the output signal, right? The output signal will be shifted. That shift is equal to the sum of the shifts t1 and t2. This is what the shift property says. The shifting property says that convolving any signal x of t with a del of t will result in x of t itself, right? So x of t convolution del of t is equal to x of t itself. So it can be understood in this way. Here this del of t minus tau is an impulse located as t minus tau, and now if you multiply this impulse with the value of the input function x of tau, it will give you x of t at that particular point. If you give the x of t value, the value of x of t, the value of the function, because this del of t is an impulse which is multiplied with the signal at that location, then it will give you the signal at that location itself, because multiplying an impulse signal with a function will result in the value of that function at that particular location. Now, if you integrate from minus infinity to plus infinity on all these results, then you will get back the x of t, that is the original signal, right? If you do it for one value, you will get the value of x of t at that particular location. If you integrate it over the interval minus infinity to plus infinity, you will get all the values of x of t. You will get all the values of x of t. In turn, we can say that you will get the function x of t back. That is the basic idea of shifting property. Now coming to the last property, which is known as the width property. The width property says that if x1 of t is having a width of t1, then x2 of t is having a width of t2, then convolution of x1 of t and x2 of t will give a signal whose width is t1 plus t2. So this property says that if the width of the signal x1 of t is t1 and the width of the signal x2 of t is t2, then the convolved result, the convolved output signal will have a width which will be equal to t1 plus t2. That is the basic idea of the width property.
I hope you got a clear idea about the properties of convolution integrals. So please keep these properties in your mind. This will be handy for you to solve different problems which we see in the subjects signals and systems and to understand different concepts from the upcoming units.